These notes are for Honors Math 3. This is Objective 10 for Unit 9, and we're going to be working on graphing secant and cosecant. So I have here just the parent functions that we're going to start with, and we'll also talk about their domain and range. We'll go on and do some translations and period changes as well. So let's start with the graph of cosecant. Now, cosecant is the reciprocal of sine. So what we want to do is start with the graph of sine. So you'll do this even with other functions that are translated, and just replace cosecant with sine and sketch this function first. What we're looking for are the 5 key points. So for sine, 0, a 0 at pi, and a 0 at 2 pi. You have your maximum at pi over 2 of 1, and your minimum negative 1. So that would create your sine graph. Now we'll just make a slightly dotted graph so we can see it in here. So this isn't the graph we want, but cosecant is the reciprocal of sine. So we're going to start with the reciprocal of our values here. Taking the reciprocal of our 0 values puts 0 in the denominator and gives us an undefined value. So for undefined values, we want to have vertical asymptotes. So that would give you a vertical asymptote here along the y-axis. Another one here when x is pi. And again at 2 pi. So you can see they're spread apart pi units. So the next thing we want to do is take our maximum 1, whose reciprocal is 1, and negative 1, the minimum, our reciprocal is still negative 1. For the values between, though, take for instance 1/2, whose reciprocal would be 2. And as you get smaller and smaller and closer to 0, every number that you take the reciprocal of just keeps getting larger and larger. So we end up with this curve here. We do the same down here. And we have the graph of cosecant. If we were to extend the sine graph in both directions, we would end up with more sketches of, or more pieces of the cosecant graph. So if we were to take our sine graph to the left and draw another period of the function, negative pi, negative 2 pi. Next would be the minimum here, and back here the maximum. So you can see another period of the sine graph. We again would draw vertical asymptotes through the zeros. And then we would take the reciprocal of all our values here. And the reciprocal of all of our values here. So I've drawn now 2 periods. So you can see just like sine repeats every 2 pi units and has a period of 2 pi, so does cosecant. So we get an up and a down curve before we repeat. And so the period of cosecant is still 2 pi or 2 pi over b, just like we had for sine. So the domain and range of the graph, when we look at the domain, you'll notice that we can have values between negative 2 pi and negative pi, between negative pi and 0, between 0 and pi, and so on. So we don't really want to list the answer that way, an infinite set of intervals that join together. So instead what we want to do is write out what values we're not allowed to have. It's an easier way to do this. We're going to write what x cannot be. So you'll notice, well, x can't be 0, pi or negative pi, 2 pi or negative 2 pi. So these numbers are all multiples of pi. So we're going to write x cannot be a multiple of pi. And the way we write that is by writing pi k, and k is just a letter we choose to stand for an integer. So if k is the integer 0, pi times 0 is 0, and x cannot be 0, true. If k is 1, then pi times 1 is pi, and x cannot be pi. If k is negative 2, then x cannot be negative 2 pi. Again, there's a value there. Okay. In writing the range, we always want to write lowest y value to highest y value. You'll notice that it's not negative infinity to infinity because there's a range of values that's missing. So we want to say negative infinity up to here, negative 1, and then 1 to infinity. So we don't actually include any values between negative 1 and 1. All right, so we're going to try the same thing here with the sketch of secant. We'll do the same thing by starting with the graph of cosine. So starting with the graph of cosine, starts on its a value 1. At pi, you've reached your minimum negative 1. At 2 pi, you're back to the maximum. So pi over 2 and 3 pi over 2 are your zeros. This would give you your cosine graph. Just like here, we take the reciprocal of all the values. So by flipping over zeros into the denominator, we end up with vertical asymptotes. These ones are at pi over 2 and 3 pi over 2. So we take the remaining values and we're going to flip them over. So starting here with 1, it's its own reciprocal. Coming down 9/10, so we flip that over. 1/2, we flip that over. We get smaller and smaller here. And the values just keep flipping over. So we do the same thing in between these two vertical asymptotes, starting at the minimum, whose reciprocal, negative 1. And then over here, you get this piece here. So you'll notice a little different looking from the cosecant graph, which we see contains 2 of these curves, just because it's based on the graph of cosine and the period of cosine there. So we see like a half, and then 1 whole curve here in the middle. So we could again extend the graph of cosine to the left and draw another period, or we could draw a half a period or a quarter of a period and draw a little bit more of our secant graph. So let's go ahead and go back with this. Negative pi, we'd be at our minimum. Okay. Again, we'd have these vertical asymptotes here. So you'll see just by getting to the next vertical asymptote, that's going to let me finish the other half of this curve. Again, from this minimum facing down, you've got this whole curve inside here, and then over here at your maximum, you're only taking the reciprocal of these values, so you'll only have this right piece. So secant's going to end like this just because of being based on cosine. The domain for the graph, we're going to write it just like we did the domain of cosecant. So we'll write what x cannot be. So this time we have x can't be pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. And if I kept going, you'll notice that at every time we get to another asymptote, the asymptotes are equally spaced. So every time I add on that distance, I'm going to find another vertical asymptote. Well, last time it was much easier because you were dealing with these whole numbers and 0 was included. So when it's not, we're just going to pick the smallest positive value, which is pi over 2. And we'll start there. X cannot be pi over 2. And then we want to say every time we add a certain distance, I get to another vertical asymptote. So that distance is pi. Okay, pi over 2 to 3 pi over 2 is a distance of pi. So again, every time I add pi, where k is an integer. And the symbol for integers there. So if k is 1, then we have pi plus pi over 2 is 3 pi over 2, and that's this one here. If k is 0, then I just end up with pi over 2, which is this asymptote here. Okay, so we either have it where it starts at 0 or it doesn't start at 0, and that's how we'll handle that. So we'll see another example here in this set of notes. You'll notice the range is exactly the same as it was for cosecant. Okay, so with that, I'm going to pull from problems on your Objective 10 worksheet to go over with you. So we'll get in another cosecant and secant graph. I'm going to start with problem number 6. Okay, so just like we did with sine and cosine, we're going to factor out this 2 and write out our values for amplitude, period, and any translation that we have here for the graph. But I also want to remember that I'm basing this on the graph of sine. So I'm going to switch over to sine and draw that in either lightly color or another color here to use. So we'll start with 2 sine. We'll factor out this 2, leaving x plus pi over 2. So remember, that allows us to see that the translation is pi over 2 units to the left. This 2 is going to affect the period length. So the period length, 2 pi over b, 2 pi divided by this b value 2 is pi. And then a is 2, so my amplitude is 2. All right, so no vertical translation here on this graph. So in starting with the graph of a sine function, remember that sine likes to start on the origin. This graph has been translated, though, pi over 2 units to the left. So from here, we're going to translate pi over 2 to the left. Okay, it's not translated up or down, so we'll start here. So remember the map for sine. It's a positive sine graph. So we want to follow first point to last point. The distance between the first and last points is the period length, pi. So if we're starting at negative pi over 2 and we add pi, we should end up at positive pi over 2. So positive pi over 2, that should be another point right here on the equilibrium. And there should be a third right in the middle, so right here at 0. So all we need is the max and the min from my equilibrium. To get to my maximum or minimum, we use the amplitude. So halfway in between here, we want to use 2. And halfway in between here, down 2. So that would give me my sine graph. So nice and dotted there. We're going to draw in the vertical asymptotes where the zeros are. So there's one here on the y-axis, and then at pi over 2. And I think we'll extend these a little. So that we have some room to draw. So cosecant exists between the asymptotes. We're going to start on the maximum. We want to draw up because the reciprocal of all of my values in here needs to come out up here. So here is this curve here. And down here from the minimum, you always draw down. So up from a maximum, down from the minimums. So there is one period of this cosecant graph. Now, each problem corresponds to a problem on 9 through 16. So 6 corresponds to problem number 14, which asks for the domain and range of this graph. So we're going to skip down to 14 and answer this question. So the domain, so just like last time, we want to list what x cannot be. So x can't be 0, pi over 2, negative pi over 2, and this will just keep going every pi over 2 units. So pi, 3 pi over 2, 2 pi, and so on. So all we need to write is x cannot be. So you would start with either your smallest positive value or 0 if 0 is an option. So x can't be 0 plus every pi over 2 units. So we'll just say any multiple of pi over 2, where k is an integer. Okay. For the range, very similar to last time. So we're looking bottom to top. You'll notice that we don't want to include any values between -2 and 2. So my range will be -infinity to -2 and 2 to infinity. You always want to start with your smallest value and work your way up here. So -infinity up to -2, +2 up to +infinity. Okay. All right. So we're going to move down to number 8. So this is a secant graph. And so, of course, we're going to start by sketching cosine. There's no b value to factor out here. So we can go ahead and check on our translation here. Negative cosine x plus pi over 4 plus 1. So we want to translate left pi over 4 and up 1 unit. So cosine always likes to start on its a value. So the a value here is -1. So we should be starting here at -1. And then we want to translate this point. So we move it pi over 4 to the left and 1 unit up. So now it actually starts right here on the x-axis. Okay, so let's go ahead and get our map for cosine. We're going to go up to our maximum and come back down. So we just did this first point. We now want to plot the last point. So remember, the distance here is the period length. Now there's no change in coefficient, it's still 1. So the period length is still 2 pi. So if you're starting here at -pi over 4 and you add 2 pi, we should end up at 7 pi over 4. So 1 pi over 4, 2 pi over 4, 3, 4 pi over 4 would be pi, 5, 6, 7 pi over 4, and last would be 2 pi. So 7 pi over 4 is when we should be finished here. and those points lie in line with one another since they're both my minimums. Here, 7 pi over 4. Okay, the next point we want to plot is the one right in the middle, which is our maximum. So remember that the total distance between the maximum to the minimum is double the amplitude. So right here we have an amplitude of 1. So the total distance is 2. So right now our minimums are on the x-axis, so my maximum must be at a height of 2. So right in the middle of these values is going to be 3 pi over 4. We'll have our maximum right here. If it helps, you can draw in the equilibrium again. That's running right through the middle. So it's that 1 unit up, 1 unit down from the equilibrium. So here we are at y equals 1. So I want to divide those remaining spaces in half. So we've got 1 at pi over 4, and then over here at 5 pi over 4. So those would be the 5 key points for my negative cosine graph. Okay. So you don't even have to draw in a dotted cosine graph, but once you have your 5 key points, now we can start working on the graph of secant. So we're going to start with drawing in the asymptotes. So this is the first time we've seen the equilibrium move off the x-axis. The asymptotes continue to go through those points, the points that lie on the equilibrium. So it's not going to be the x-intercepts that they pass through, it's going to be these points here. Okay. Our graph of secant, we want to start on any minimum and draw down and toward the vertical asymptote. So this minimum as well. Start on any maximum and draw up toward the vertical asymptotes. Okay. And so once we have our sketch, we can do the corresponding problem number 16 here, which again asks for the domain and range. So once again, we have a vertical asymptote not starting on the y-axis. So my domain, x cannot equal. We'll start with our smallest positive value, pi over 4. And then we want to add on to that the distance between the asymptotes. And you can do this every time. So the distance from pi over 4 to 5 pi over 4 is just going to be pi. So plus pi k, and again where k is an integer. The range, negative infinity up to 0, and 2 up to infinity. Okay, so now you've seen 2 cosecant graphs, 2 secant graphs. You've got just a few more left on the assignment to go through. At the end of the assignment, there's a little bit of review, so I just want to go over 2 of the problems there with you. So this is from problem 17 through 31. I'm going to start with problem number 24. Okay, so it's review plus. So you're evaluating a trig function at an angle, and you're doing a little bit of other stuff here to simplify this to a value. So we want to evaluate first here sine of 3 pi over 2 and square it. So what's really happening right here is you're finding sine of 3 pi over 2 and then squaring it. Writing the square here is just another notation for the same thing. So sine at 3 pi over 2. So remember that 3 pi over 2 is here. Corresponds to a point. on our unit circle, meaning we're 1 unit away from the origin. So this would be a coordinate pair of 0, -1. And you'll remember that sine is the y value here. So sine would be -1. So sine of 3 pi over 2, -1. -1 squared is 1 times 2 plus 3. We end up with 5. So that's all there is to these problems. And I'm just going to do one more problem with you then. So this is number 28. All right, so these both use pi as the angle. So again, pi would be here, corresponds to a point on our unit circle. So we are 1 unit to the left of the origin. So this is the point -1, 0. So we'll keep our 4. Secant of pi. So secant's the reciprocal of cosine. Cosine is the x value, -1, the reciprocal, -1. Tangent at pi. So tangent is y over x. 0 divided by -1 is 0. And so I end up here with 4 plus 1, which is 5. All right, so that's everything that you'll need to know for Objective 10.